So for today's topic video, we're going to be talking about the difference between average rate of change and instantaneous rate of change. So first things first, I'm going to go ahead and put up a little graph here as a reference point. So let's just say I have something like this. And let's say we take this point right here and some other point. Let's do the point over here. So the general idea is that if you're doing average rate of change, then visually what you're going to get is, first of all, you need 2 points, which is why I put 2 points here. When you do average rate of change, you're getting how much you're changing in between those on average, just like it sounds. So the line for the average rate of change between these 2 points would look like this. And you notice that line does not match up entirely with the graph. It has these 2 points where it cuts through, but this is way above here, and then this dips down a little bit, and then we're over here. And so when we get an average rate of change, we're just getting, again, an average, something that's close or an approximation to what the change was in between these 2 points, even though at all the points in between, the actual rate of change may be different. Instantaneous rate of change, however, is indeed at one point what the exact rate of change is. So for example, if I did the instantaneous rate of change here, that would look like that, because that's the direction in which the graph is changing. That's its slope at that point. Likewise, if I did the instantaneous rate of change right here, it would look like that, because that's the direction in which the graph is going right there. So for instantaneous, we need 1 point, whereas for average, we do need 2 points. And the reason for that is that the formula for average looks like this. So if this is a function f, this graph I have here, f of x, and if I call these points, let's say x1, x2, and I want the average rate of change from x1 to x2, then the formula would be f of x2 minus f of x1 over x2 minus x1. That would be your average rate of change between these 2 points. Remember that f of x is just the point on the graph. So f of x2 would be this point here, and f of x1 would be this point right here. So you need 2 points because you need to know in between where you're getting this average. Instantaneous, on the other hand, that's where the calculus comes in. It is just the derivative. Remember that the derivative of a function is the slope, or the rate of change at that point. So if I want the instantaneous rate of change, I just need 1 point and the function. So I need my f of x. And then all I do is I just do f prime of x. And if I want the rate of change at a point, I would just plug it in. So f prime of x1 would be the rate of change at x1, and f prime of x2 would be the rate of change at x2. So this orange arrow and this orange arrow. Now, you also have the limit definition involved. So instantaneous rate of change, remember that the derivative, you could say that's the limit as h goes to 0 of f of x plus h minus f of x all over h. And all you're doing there is you're taking some arbitrary other point, so you could say it's like right here, and you're just letting it approach closer and closer to the curve. And so you can say that that distance right there is h. And so if you're taking h to be some distance away from the point you're trying to find the slope at, you just let h get smaller and smaller and smaller until you're right on top of the point. And so the limit is the derivative is defined as a limit as h goes to 0 in that way. And so that's the main difference. If you're doing instantaneous rate of change, you need calculus, right? And you would just do the derivative and plug in the value. If you want average rate of change, you don't really need calculus, but you do need 2 separate points because you need to know where am I starting at and where do I end. And so that would be the difference between average and instantaneous rate of change, and that was today's topic video.